Welcome to Meera Codes. In our previous video, we learned about the integer data types, byte, short, int, and long. All of them are used to store the whole numbers. Now we are moving to the decimal numbers. In this video, we will learn about the float data type. Float is a primitive data type in the Java. It is used to store the numbers that contains the decimal point. For example, 99.9936.5, 5.8. A float occupies the 4 bytes of memory. Since 1 byte contains the 8 bits, 4 into 8, that is 32 bits. Why do we need a float? Suppose if we want to store the someone's age can be represented as a 25. That's a whole number. So we can use the int. But suppose if you want to store the someone's height like 5.8, 5.9, 6.1, that contains the decimal value. For such values, we need a floating point data type such as a float or a double. So the data types like a short, byte, int, and a long, these are used to store the whole numbers. Float data type is used to store the decimal numbers. Memory comparison. Int and a float both uses the 4 bytes of memory to store the values, but they don't store the same type of information. Int is used to store the whole numbers, float is used to store the decimal numbers. Similarly, long uses the 8 bytes and stores the large whole numbers, while the double uses the 8 bytes and stores the decimal numbers with a higher precision. Why do we use a f suffix? If we want Java to treat it as a float, we add the letter f at the end of the value. This means it is a float literal. So, for example, float price is equal to 99.99 f. So, in the value, I have added the suffix f. This will be treated as a float literal. What happens without f? So this is one of the most important concept. At first, the price is of type what? Float data type. And the value is a decimal number. Okay. Still, it shows the compile time error. So why there is an error? The most important thing is that Java does not automatically treat every decimal number as a float. It treats the decimal literals as a double by default. So when it sees 99.99, right, this is a decimal literal, it treats a double by default, and we are trying to assign double to the float. Conceptually, how Java sees is like when we when we declare or assign the value 99.99, it internally assumes it as a double data type. Double temp is equal to 99.99. But what I have declared is it is of a type of float. So now internally it should convert double to the float, right? So there will be a possible of loss of precision. That is why it gives the compile time error. So converting a Java to the float, it can potentially lose the information. Java therefore does not automatically perform this conversion. That is why we will be getting the compile time error. So now the Java, like if we add the suffix f, the Java sees that it is a float literal. So the assignment will be valid in this case. So let's understand few cases here. So first one is a float. A is equal to 10.5 f. So f says this is a float. So it is a valid. Second one is a double. B is equal to 10.5. Decimal literals are double by default. So this is also valid. So float C is equal to 10.5. 10.5 is a double by default. We are trying to put a double value into a float type. So that can lose the precision. So Java does not allow it automatically. It gives the error. Fourth one is double D is equal to 10.5 F. A float here, the value F value is a float because I have added the suffix F. A float can be automatically converted to the double because double provides the greater precision, so it is a valid. So now this is related to widening and the narrowing conversion. First one is converting from float to the double. Java can automatically convert this because a float has a lesser precision than the double, because we are moving to a type that can represent more precision. So this is called as a widening conversion. The second one is a double to the float. So this is narrowing conversion. Some precision may be lost. Therefore, Java requires us to explicitly indicate that conversion if we really want it. For example, I have a double value is equal to 99.99. Value is the variable, double is the data type. This is the value that I have assigned to the variable called as a value. Here, I'm telling explicitly like convert this value. Value is what? This is a variable name. Okay, value is a variable name. Convert this variable, that is value, to the float. Okay, and store it in the variable called as a number, which is of type float data type. How much can a float store? A float uses the 32 bits. Unlike integer types, we cannot calculate its range by using a simple integer formula like minus 2 raised to n minus 1 to 2 raised to n minus 1 minus 1. That's because float uses the special floating point representation. A Java float provides the approximately 6 to 7 decimal digits of precision, and the approximate range is plus or minus 1.4 into 10 raised to minus 45 to plus or minus 3.4 into 10 raised to 38. The important point is the float can represent very large and a very small decimal values, but with a limited precision. Precision example. Here we should understand the idea of a precision. So float does not provide the unlimited decimal accuracy. It gives approximately 6 to 7 significant decimal digits of precision. So when we work with the values that requires very high accuracy, float may not be suitable. So that is one of the reason Java also provides the double data type. When to use the float? We can use the float when we need decimal values but don't require very high precision. For example, like to store the temperature, height, weight, distance, and percentage. Scientific calculation where very high precision is not required. However, like for many decimal calculations in the Java, double is preferred because it provides the higher precision. So today we learned about the float data type. We understood uh, why the float is used for the decimal numbers and it occupies the 4 bytes of memory, and why the Java treats the decimal literals as a double by default, and why we need suffix f when assigning the decimal value to the float. And in the next video, we will learn about the double data type, which provides the higher precision than the float. Thank you for watching.